Hello, good evening to all. So last classly നമ്മൾ നടത്തിയത് reciprocating pump, single act, and we started the working of reciprocating pump, double acting. So double acting means simply we have water on both sides of the piston. So amount of water in the right side of the piston and amount of water in the left side of the piston. So in the right side of the piston, you can calculate the area of volume of water is equal to area into stroke length. So area equal to area of the cylinder gives the area on the left side of the piston, and area in the right side of the piston, it is area of the cylinder, and there is a small portion called the rod, piston rod. We have to subtract that area. So area on the right side of the piston is equal to pi by 4 into cylinder square minus pi by 4 into d square. So total area. And in the forward stroke or in the suction stroke of the left side, there is a delivery stroke on the right side, and for the delivery stroke on the left side, there is a suction stroke on the right side. So in one complete revolution of the motor, we got 2 suction stroke and 2 delivery stroke. The total discharge will be doubled or almost doubled. So volume of water delivered in one revolution is equal to A into length of stroke for left side and A1 into length of stroke for the right side. So A and A1, A is the area on the left side and A1 is the area on the right side. A ഉണ്ട് area A into length of stroke, remaining ഒരു ചെറിയൊരു വേരിയേഷൻ മാത്രം. റൈറ്റ് സൈഡിൽ പൈ ബൈ 4 d സ്ക്വയർ, റൈറ്റ് സൈഡിൽ pi by 4 d square into small d square. So in every equation it will come, but in general we will neglect the small d and we will be writing pi by 4 d square plus pi by 4 d square. Q is equal to ln by 60 of the previous equation. Now it will become 2 into ln by 60 will be the equation for the double acting reciprocating pump. And for the work done equation, everything will be multiplied by 2. Here 2 ln by 60, work done 2 into ln by 60. Everything is multiplied by 2 for a double acting reciprocating pump. The next thing we are going to discuss is the slip. Slip means there is a difference between theoretical discharge. Theoretical discharge we have equation Q into ln by 60 and actual discharge. ലാബിൽ ആദ്യം ചെയ്താണ്, ലാബിലെ ആക്ച്വൽ ഡിസ്ചാർജ് മെഷർ ചെയ്യുന്നത് മെഷറിംഗ് ടാങ്ക് വെച്ച് മെഷർ ചെയ്യുന്നതാണ്. അപ്പോൾ ഇൻ ജനറൽ കേസ് ദർ ഇസ് എ ഡിഫറൻസ് ബിറ്റ്വീൻ തിയററ്റിക്കൽ ഡിസ്ചാർജ് ആൻഡ് ആക്ച്വൽ ഡിസ്ചാർജ്, ആൻഡ് വി ഹാവ് മെനി വാല്യൂസ് ഫോർ CD, for Venturi meter, orifice meter, rectangular notch, like that. So that is called a slip, and a percentage slip means divided by a common factor Q theoretical minus Q actual divided by Q theoretical. So and the ratio between actual and theoretical gives the CD, coefficient of discharge. And for the reciprocating pump only, in some case we got a negative slip. Negative slip means Q theoretical minus Q actual value become negative. That means actual discharge is greater than the theoretical discharge. This only happen in reciprocating pump. There is a reason for it. Delivery pipe too short and suction pipes too long, pump running at high speed. These are 3 conditions. If these conditions are satisfied, we will get a actual discharge more than the theoretical discharge. So slip negative means theoretical value is less than the actual value. This occurs in 3 reasons: delivery pipe too short, suction pipe too long, pump running at a high speed. And classification of reciprocating pump based on the double acting, single acting we have already discussed. If we are dealing with water on the one side of the piston, we will be calling it as a single acting pump. If we are dealing with water on both sides of the piston, we will be calling it as a double acting reciprocating pump. And if we are dealing with more than one cylinder, we have discussed only single cylinder reciprocating pump. If we are dealing with 2 cylinders at the same time, we will be calling it as a double cylinder. So all of you know that because many bikes are coming with V engines and many cars are available with the 4-cylinder like that. So you know the difference. Okay. And here are two problems. These two problems are direct substitution. So I hope you will complete this as a homework, and if you have any doubt, you can refer the textbook or you can ask me. Okay. So please take down these two problems for your homework. And you will be going to some important derivation for this reciprocating pumps. In connection with this derivation, we have to study two more derivations for reciprocating pumps. So just understand the concept of this derivation. You just understand the concept of this derivation. Okay. Here is the schematic representation of a reciprocating pump connected to the engine motor. Now it is marked X as the distance moved by the piston, and the crank is rotating in a clockwise direction. Let omega be the angular velocity of the crank in radians per second. And r is the radius of the crank, and theta is the angle turned. If x is the distance moved here, you can also see the distance x here, because we have already mentioned that the stroke length is equal to 2 times the radius of the crank. So if I can rotate 180 degree, the piston will be moving from top dead center to bottom dead center. So x we have marked here, and we can also mark the point x here. R everything is marked. And if theta is the angle turned by the crank, it can be written as omega t. So omega is the angular velocity in radians per second. So it is worked over 1 second. The total angle turned will be omega into t, will be the angle of theta. So x is the distance moved by the piston. So we can write the equation for x as AF. AF can be written as AO minus FO. So AO can be seen from the figure. It is the radius of the crank. So AO can be written as R, and OF. OF is the portion of a triangle EFO, or I can write triangle with the hypotenuse R. So I can write OF equal to R cos theta. So I can write the x distance as R minus R cos theta as the distance x. Okay. So I'm going to calculate the velocity and acceleration of the suction and delivery pipe due to the acceleration of the piston. So first I will calculate the velocity of the piston. So x is the distance moved by the piston. The relation between velocity and distance equal to first derivative of the distance will give the velocity. So dx by dt will gives you velocity. So I will calculate the velocity of the piston as dx by dt. d by dt of x equal to, I got the value, r minus r cos omega t. So d by dt of r minus r cos omega t. So d by dt of r constant, so it will be 0. And minus r cos omega t, minus r is constant, it's taken outside. Cos omega t, it will become minus sin omega t and into omega. So here one minus is there, one more minus is there, it will become r omega sin omega t. So velocity of the piston is given by r omega sin omega t. And this is the velocity of the piston. So, and we are calculating the variation of velocity and acceleration in the suction and delivery pipe. So I had to connect the velocity of the piston to the delivery pipe or suction pipe velocity. Whatever be the water inside the cylinder will be delivered to the suction or delivery pipe. So water will amount of water will remain constant. So area into velocity of inside the cylinder will be equal to the area of the in the pipe into velocity inside the pipe. A1 V1 equal to A2 V2 and integration. So applying that, velocity in cylinder into area in cylinder equal to velocity in pipe divided by area in pipe. So I had to calculate the velocity in pipe. So V is equal to capital V into A by A. So capital V already got omega r sin omega t. A by A into omega r sin omega t will give the velocity inside the pipe. And next step is calculating the acceleration. So velocity and acceleration relation. First derivative of acceleration will give the velocity dv by dt. So dv by dt is a omega sin omega t. Sine will give you cos omega t into omega. So omega will come outside. So a by a omega square r cos omega t will give the acceleration of water inside the pipe. Okay. So we have derived an equation for acceleration of the water pipe. Now we are going to calculate the force required to accelerate the water. Force equal to ma, F is equal to ma, mass into acceleration. Acceleration we already got the equation as a by a omega square r cos omega t. So force equal to mass into acceleration. So mass equal to density into area of the pipe into length of the pipe. So it will give us the mass of the volume. So rho al into a by a omega square cos omega t. This is the force. I want to calculate the pressure. So pressure equal to force by area. So again I am dividing the whole equation with the area of the pipe. So what is the intensity of pressure inside the pipe? So rho al a by a omega square into divided by area of the pipe. It's already mentioned that area of the pipe is equal to small letter a. So dividing by small letter a. So we are calculating the two a's here. So rho l into a by a omega square r cos omega t. This is the intensity of pressure. So I want to calculate the pressure into head. So P is equal to rho gh or H is equal to P by rho g. So H can be written as pressure divided by rho g. So rho l a by a omega square cos omega t. Omega t is replaced by theta. So divided by rho g. So rho and rho get cancelled. L by g a by a omega square cos theta will give us the equation for head due to acceleration. So it is a general equation. If I am writing this equation for head in suction pipe, H it will become HAS, L become length of the pipe, LS, and A become area of the suction pipe, AS. If we are dealing with the delivery pipe, HAD, head root to acceleration, the delivery pipe is given by length of delivery pipe divided by gravity into A is the area of the cylinder divided by area of the delivery pipe into omega square r cos theta. So we got two equations. Now we are going to check when it will become maximum or minimum. So we got the value head due to acceleration LS by AS, A by AS omega square r cos theta. As the crank rotates, the only variation is the angle theta. So initially the angle is equal to 0. So initial position starting from the point A, angle equal to 0. When it will become 90, it will reach the point B, and when it will become 180, it will reach the point C. So initially at the beginning of the suction stroke, theta is equal to 0. At the middle of the suction stroke, theta is equal to 90. At the end of the suction stroke, theta is equal to 180. So when theta is equal to 0, cos theta is equal to 1. So maximum acceleration will be at theta is equal to 0, and at theta is equal to 90, acceleration is equal to 0, and at theta is equal to 180, acceleration will become negative. So minimum acceleration will be at end of the suction stroke. So maximum acceleration is equal to at the beginning of suction stroke, and the minimum acceleration at the end of suction stroke. So maximum pressure head due to acceleration is given by L by G A by A omega square, L by G A by A omega square. So it's a very important derivation. You just go through and try yourself. If you have any doubt regarding the derivation or calculating some value differentiation like that, you can directly email me, or you can send message in my WhatsApp. Hope you got a brief idea how we are going to do the derivation in reciprocating pump. It's a connection with the upcoming derivation, so please understand it thoroughly and clarify your doubts. Thank you.